and welcome to Nkumat Online Academy. We are back to our discussion on mapping, and we want to talk about mapping as a function. Mapping as a function, that is what we have today. We've talked about, or we rather introduced what mapping is all about. We talked about domain, codomain, image, and the range. So today we are going to look at how mapping functions as a function or works as a function. When we have x and y values in an expression, we always express this as a pair where we write x first and then write y. Like when we want to create a coordinate of values, if we want to create a coordinate of x and y, maybe if we want to plot a graph, we always write the x before we write y. So two of them always go together, x and y, as a pair. Now in mapping, these x values represent the domain and the y values represent the range. Of course, we know that in mapping, the range is a collection of the images in the codomain. Because in mapping, some values in the codomain may not have any associated value in the domain. That means that some values in the codomain are not image of any element in the domain. We established it in the previous lesson. Now that means that in creating a pair of x and y in mapping, we are not always concerned with all the elements of codomain, but only the elements that have associated values in the domain. And the elements in the codomain that have associated values in the domain are the images. So we always talk about the images and the elements in the domain. Now the images in the codomain are expressed as fx. That is the function of x. So anything we write as the function of x, which we write as f of x, f of x of any value is an image that represents the value of y in the codomain. So instead of us having x and y pair in mapping, we have x and fx or f of x pairs. So what we have in mapping, instead of writing x, y pair, we have x, x, and f of x pairs. This represents the normal values in the domain, while the f of x represents the elements in the codomain that have associated values in the domain. Fx is an element in the domain. X is an element in the domain, while f of x is an element in the codomain that has an associated value in the domain. So we are removing x because if we are removing y because if we want to include y, that means that we are talking about all the elements in the codomain, because y as a whole represents all the elements in the codomain, but we are not talking about all the elements in the codomain. We're only talking about the ones that have or that are image of a value in the domain. So that's why we are talking about x and f of x when we are expressing the function or a function in mapping. Now, just as a recap, I said that a set of all the x values is the domain. So when we get a set, when we get all the x values, we put them together, we call the set a domain. And when we get all the f of x values, we put them together, we call it a range. Now let's look at some examples. In this example 1, we are asked to find the if a function of x such that x is equal to 2x plus 1, find the range of x equal to 1, 2, and 3. A function of x such that x is equal to 2x plus 1. Find the range for x equal to 1, x equal to 2, and x equal to 3. Now, what do we do here? Or what is this asking us to do? This thing is telling us that we have this value, then we have this. We already know this is always the x and this is always our y, but in mapping we are not always so much interested with y. We are always so much interested with the f of x. So if this represents a set, y represents a set, the values inside it will be equal to f of x. So for each value in x, the x values are this. We have 1, we have 2, we have 3. Now each of them will be associated with a value in the codomain, that is y. So that is what we are going to look for. We are going to use this expression. This expression is called a relation that exists between the x and y. It is from this that we establish what will be inside these sets. So for us to find the f of x, that is what they're asking us in this question, that we should get the f of x. If you get all the f of x, each f of x represents an image. And we've said here that a collection of the images, that is a collection of the f of x, is equal to the range. So for us to get the range, we get all the f of x in this codomain and put them together in a set, and that gives us the range of this function. So let's start with number 1. For when x equal to 1, then we know that f of x in this expression is equal to 2x plus 1, and that means that if we put f of 1 is now going to be f of 1 is equal to 2 bracket 1 plus 1, which is equal to 2 plus 1, which is equal to 2 plus 1 is equal to 3. So f of 1 is equal to 3. That means that 1 in the domain maps to 3 in the codomain. So the image of 1 in the codomain is 3. So this maps to this. Now when we have x equal to 2, then the expression becomes, or the function becomes, f of 2 is equal to 2 bracket 2 bracket 2 plus 1. So we have 4 plus 1, which is equal to 5. So when x is equal to 2, f of x is equal to 5. So the image of 2 is 5 in the codomain. Now for the last one, 3. For the last one, where we have x equal to 3, then that means that f of 3 is equal to 2 bracket 3 plus 1. That gives us 2 times 3 is 6 plus 1, and this gives us 7. So we have that 3 in the domain maps with 7 in the codomain. So we have 7. 7 is the image of 3 in the codomain. So this represents or gives us the images of the values in the domain. So for us to get the range, let's call the range R. If R set represent the range, then this set is equal to all the images in the codomain, which are 3, 5, 7. This is the answer. So our range is equal to 3, 5, 7. I hope this one is clear. Now let's look at another example. Example 2. Determine the domain D of the mapping function of x such that x is equal to 2x minus 3. 2x minus 3. Now here we have the domain is D, and the function of x equal to this if C is equal to minus 3 minus 1 5 is the range, and f is defined on D. Okay, so this represents the range. A collection of the images in the codomain is the range. So we're actually going to map this with this. So we already have the images in the range in the codomain. The images in the codomain is called the range. So we have it as minus 3, minus 1, and 5. So here, instead of asking us to look for the range, we are given the range and we have to use it and get the domain, the values or the elements in the domain. So how do we do this? we still pick the relation that is the expression that connects the x and fx. That is this. That is the function given to us. Now it means, like we said in this place, we say that f, the function of x such that x is equal to y, means that f of x is equal to y. So that means here that if if f is a function of x such that x is equal to 2x minus 3, then f of x is equal to 2x minus 3. F of x is equal to 2x minus 3. Now that means that we already given the f of x, that is the range. So all these values here are different f of x. So when we pick minus 3 as the first f of x, then we have that minus 3 is equal to 2x minus 3. And so we have that minus 3, this coming to this side, plus 3 is equal to 2x. And that gives us that 0 minus 3 plus 3 is equal to 0 is equal to 2x, and then our x is equal to 0. So for the first value of f of x, it is equal to x in the domain is equal to 0. So it is 0 that gives us the image minus 3 in the domain, in the codomain. So we are trying to establish the values that created these images. Now we pick minus 1. For minus 1, remember we said that f of x, the rule is that f of x is equal to 2x minus 3. Now for minus 1, we have that minus 1, that is when f of x is equal to minus 1. Minus 1 is equal to 2 bracket minus 1 minus 3, which is equal to minus 2 minus 2 minus 3. Sorry, this is not, we are looking for x. We already have minus 1 as the f of x, now which is equal to now 2x minus 3, and we have that minus 1 plus 3 is equal to 2x, and 2x is equal to 2, which means that x is equal to 2 divided by 2, which is equal to 1. So we have 1 here. It is 1 that gives us the image minus 1. Now the last one, In the last one, where we have that f of x is equal to 5, that means that 5 is equal to 2 5 is equal to 2 times 5 minus 3. Why am I writing this? 5 is equal to 2x minus 3. 5 plus 3 is equal to 2x. 8 is equal to 2x, which means that x is equal to 8 over 2, that is 4. So we have 4 here. So it is 4 that gives us the image 5. So we have created the values in the domain that gave us the range -3, -1, and 5. So we have determined the domain. This is the domain 0, or the set in the domain. The element in the set domain D is equal to the element equal to 0, 1, and 4. 0, 1, and 4. So this is how to solve this one. Now let me solve this one example again. Determine the domain D of the mapping G is a function of x where x is equal to 2x raised to the power 2 minus 1 if R, which is a set of 1, 7, and 17, is the range and G is defined on D. So we also have this, and we also have this. We draw this to give us a pictorial representation of what we are looking for. Now, which one is given to us? We have the range, which is the value of the F images in the codomain. So we have 1, we have 7, and we have 17 in the set R. Now we are looking for D, which is the domain. Now the relationship is G. Remember that a function can be denoted with anything. We can have it as A, F, G, anything you like. You can use it to denote your function. So it's not a must that you use F to represent the function. So here we are using G. So we have that G is a function of x such that x is equal to 2x raised to the power 2 minus 1. Now this means that g of x is equal to 2x raised to the power 2 minus 1. Now when g of x is equal to 1, we have 1 is equal to 2 raised to power 2, 2x raised to power 2 minus 1. And so we have that 1 plus 1 is equal to 2x raised to power 2, and 2 is equal to 2x raised to power 2, and that gives us that we now have that x raised to power 2 is equal to 2 over 2, which gives us 1. And so the root of 1 will give us x. X is equal to root 1, which gives us 1. So we have 1 here. So it means that it is 1 that gives us the image 1 in the codomain. 1 gives us 1 in the codomain. Now let's look at 7. For 7, we still have our g of x is equal to 2x raised to power 2 minus 1. So we have that when g of x is equal to 7, we have that 7 is equal to 2x raised to power 2 minus 1. And we have that 7 plus 1, that is bringing this one to this side. 7 plus 1 is equal to 2x raised to power 2, and 8 is equal to 2x raised to power 2. So we now have that x raised to power 2 is equal to 8 over 2, which is equal to 4. And then our x is equal to root 4, which is equal to 2. So we have that the value that gives us 7 as image is equal to 2. So 2 gives us 7 as an image. Now let's look at 17. For 17, still taking our g of x is equal to 2s raised to power 2 minus 1. Then we have that 17 is equal to 2x raised to power 2 minus 1. And 17 plus 1 is equal to 2x raised to power 2. 18 is equal to 2x raised to power 2. This means that this gives us that x raised to power 2 is equal to 18 over 2, which is equal to 9. And therefore, our x is equal to root 9, which gives us 3. So we have here 3. So the value in the domain that gives 17 using this relation is equal to 3. So 3 maps to 17. So these are the values in the domain according to this function. So we can now say that the set of our D is equal to or it contains the elements 1, 2, 3. This is the answer. So we've gotten our domain as a set that contains the values 1, 2, 3. I hope this is very, very, very clear. Thank you.